Hi everyone, welcome to the session on Gemini AI. I'm Yashaswini Vishwanath from Bangalore, India, and I have been in the IT industry for the last 13 years. I like generative AI and I'm pursuing my PhD in generative AI. Today, I want to take a session on telling about the capabilities of Gemini AI in the generative AI space. I hope you find the session useful and interesting. Let's dive in. Hi everyone, I'm Yashaswini Vishwanath, and today I'm here to talk about Gemini API. Let us learn about Gemini API, how we can leverage on Gemini API in the generative AI space. First of all, what is generative AI? We have been hearing the term generative AI all around us. It is this technology that can bring out text, images, audio, video. It can generate these type of content for us by giving text prompts or other modes of input. What is an LLM? You have heard the abbreviation LLM, and today I want to talk about what is LLM. It's a neural network that models the distribution of the text on which it's trained. It can take input like it's raining cats and dogs and give the next word based on what it has seen in its training data. So, a large language model is essential a sophisticated autocomplete. Roses are red. Say a model trained on poetry will predict output that's violets are blue, sugar is sweet, or a model trained on code samples will produce output. We have seen many code generation LLMs now. The science behind that is that they are done using lot of code sample training. We have given it a lot of code to learn, and using that, it has learned. Modern LLMs are large. The current generation of LLMs are trained on large, diverse data sets, representing all kinds of language and context from around the web. These models have billions, sometimes even trillions of parameters. So they capture language structures more complex than we have seen in previous generations, like your phone's autocomplete. The classic natural language problems are entity extraction, where we talk about the different entities like a noun or a verb, the classification, summarization, sentiment analysis, translation, so on and so forth. This makes them useful for a number of common classic NLP tasks that we have previously would have trained task-specific models for. LLMs are used here. LLMs let us prototype fast. On top of all these abilities, LLM let us prototype AI-driven applications really, really fast. This is huge because traditionally building an ML-powered app would mean collecting potentially thousands of examples for your domain and then training or tuning a model before you can start to evaluate or even explore its suitability. This took a lot of time and resources. But with LLMs, you can start to explore an AI powered area in just minutes, and you don't need ML expertise. Thanks to their massive size, LLMs are also able to perform well on new class of human language tasks, like explaining humor. For many tasks, you can just ask the model to do it and it does. Explain this joke. I used to be addicted to soap, but I'm clean now. So the model explains why is the joke funny? Because it's unexpected. The listener expects the speaker to be talking about the first meaning of clean, but they're actually talking about the second meaning, which is related to alcohol. Give me five neat ideas for science fair projects. See, this is an idea where you have creative outputs from the LLMs, like build a volcano, make a solar oven, create a 3D printer, build a robot, design a water filtration system. The LLM is thinking through and giving you creative ideas. Why are large language models different? They have emergent abilities, which mean they do not have to be explicitly trained to do things. You can train it on a large corpus of text and it learns to translate, answer questions, code, and so on. Next, LLMs can change how we interact with intelligent systems because of their contextual understanding of human language. With an LLM, a SQL query can become a simple question. Need to find information on a website? Type it in a chatbot. Finally, LLMs are the next in our machine learning journey. Many years ago, you would use a simple regression to find a pattern. Then, with neural networks, you were able to unlock hidden patterns in a much larger data set. Now, with LLMs, we can find patterns and connections in massive, disparate data sets. Google is the industry pioneer in AI. Generative AI is the top mind for us, for all our customers, for our competition at the moment. Everyone is talking about it. Here we see how Google is a pioneer in AI. We have open sourced AI more than any company in the world, 3,000 researchers, 7,000 publications all over the world. Generative AI is in the DNA of Google and it is always looked at responsible AI. Here we see in 2015, we have the Google's DeepMind AlphaGo defeats Go Champion. Go is a game which uses intellect, and Google DeepMind AlphaGo it defeated Go Champion. In 2016, Google's DeepMind helps detect eye disease. 2017, Google invents Transformer, kickstarting LLM revolution. You've been hearing the word transformer all through. It came out in a paper called Attention is All You Need. 2018, Google's groundbreaking large language model BERT, bidirectional encoder representation transformer. Text to text 2019 text to text transformer, LLM, 100 billion parameter model open sourced. 2020, Google Lambda model trained to converse with humans. In 2022, AlphaFold predicts the structures of known proteins. This comes under the purview of biotechnology, genetics. In 2023, a conversational AI service powered by Palm 2. 2024, a family of multimodal LLMs and products. Multimodality. What is multimodality and why is it important? Can't we just do with multiple models working together? A signal is lost between the models. Like an audio input contains tone and emotion that is lost in text. That is why we need multimodality. Here in the picture that you see, we have text, audio, picture, video, We send all this to the transformer, which will have an image decoder and a text decoder and will help us to generate new image and text. Welcome to the Gemini era. There are three Gemini model sizes: Ultra, the most capable and largest model for the more complex tasks; Pro, the best model for scaling across a wide range of tasks; Nano, the most efficient model for on device tasks, available through Android AI Core. Gemini models are built from the ground up for multimodality reasoning seamlessly across text, images, video, audio, and code. Gemma is something that is an open source model that has come from Google, and Gemma is the next LLM that you have to look at. Gemini is the most advanced AI from Google. For consumers, Gemini helps them make apps on the web. Gemini in the Google app can be integrated. Gemini in Gmails, Docs. Gemini for developers. Gemini API. Gemini API can be used in Google AI Studio and developers can leverage on it. For business and enterprise, Gemini for Google Workspace, Gemini for Google Cloud, Gemini in Vertex AI. Let's start with Gemini API. How do we generate the API keys? How do we create, test, and save prompts? How do we customize models in minutes? How do we generate starter code? This is Google AI Studio. It's a web interface to the Google's API that you can use it to quickly prototype and riff on your ideas in the browser without writing any code. In AI Studio and with Gemini API, you can just ask the model what you want it to do using plain human language and get results in seconds. Then, when you're ready, Google's AI Studio will help you move your prompt into your app, starting off the fly, getting the API key. This will give you access to do anything on AI Studio. Think of it as a password to access Gemini. Select the model that you want to use. This is Google AI Studio. It's a web interface to the Gemini API that you can use to quickly prototype and riff on your ideas in the browser without writing any code. So you can just ask the model, what is it that you want using plain human language, and you get the result in seconds. And then you can move the prompt to the app. Here you can use the widget to get the code in the language that you are interested in. Then you're ready. Google AI Studio will help you move your prompt into your app. In the prompt UI, there's a Get Code button that will show you code snippets for a number of languages, and they are pre-filled with your prompt and use the same exact settings you used in AI Studio. There's even an option to load a Colab notebook that's pre-filled with your prompt and settings. The Gemini API is a REST API. That is, you can call directly or using one of the user-friendly client libraries in Python, JavaScript, Swift, Java, Go, Flutter. This presentation uses the Python SDK as it is the most popular language, but everything should be possible using the API directly. Vertex AI. Now, Gemini API and Vertex AI, how are they related? They both give access to the Gemini family models. Vertex AI Generative Studio gives the same access to the models like Gemini, and we have kept the APIs as close as possible to make migration to the cloud as easy as possible. We expect individual developers to start with Gemini API and move to Vertex when they need access to commercial support and higher rate limits. If you're already cloud friendly or cloud native, then you can get started in Vertex straight away. Usage patterns. Here, we will cover the overview of usage patterns, basic prompting, code generation, search, retrieval, and information synthesis, function calling, image understanding, tuning. What is basic prompting? This is the place to start with basic prompts, that is, simple prompts. Say, a creative prompt like write a poem about a magic backpack. And the model would happily give you a poem with many verses, rhyming, etc. This example went on for a bit. I have saved you from I have saved for you most of it. This makes for a nice example, but in practice, you're unlikely to do something this simple. It says, in a world of wonder, behold, a backpack with tales you untold, its fabric shimmer alive with might, a portal of realms day and night. This is a small poem that Gemini has written for us, given the prompt that we have given. Let's imagine we want to send a tip with our daily JavaScript newsletter. So this is the basic instruction prompt with some extra guidance. We say, generate a short tip about JavaScript. Good tips are short and contain a code example showing the tip. Now, this is what Gemini creates. It says you can use array like this and you can log it like this and see the output. One issue with the kind of prompt is that when you always use the same input prompt, you're going to see repeated outputs very quickly. When you can request some diversity and creativity through the model settings. How do we make the changes in the model settings? And what are these settings? It's the temperature and number of outputs. It'll buy you a little time, run away. But for this example, we want unique output forever. This time we have added examples. We call this a few short prompt as we give the model a few examples of which the input output should look like and it continues the pattern. Technically, this is a one short prompt as we have only one example. We leave the prompt hanging at the end so that the model will continue at exactly this point generating the tip itself. Here's how it looks in AI Studio, where it's called a structured prompt. Another subtle difference with this prompt example is that each output is conditioned on a topic. It does not mean that I need to provide a topic to generate a tip, but remember, you can always ask the model to generate 100 for you or have it suggest topics based on your newsletter content. Topics are also much easier to deduplicate programmatically than entire tips. Now, let us look at a basic text interface in Python. You can dig into some of the other fields in the response too, like the prompt feedback, which will tell you about any safety filtering that has happened. Citation metadata, which will tell you about any text that has been identified as duplicated on the web so you can cite your source. And here is a chat interface. Chat has conversational state. If you are making new raw API calls, you'll need to manage that yourself. If you use the SDKs like I have here, it's taken care for you. This statelessness has benefits though. It means you can save and resume conversation and even edit history if you need to. Here we generate content request. We have the settings, the configurations, and we have the contents, and thus we generate. The candidate content, it's only one candidate returned today. Why has the model stopped generating? This is the finish reason. The finish message, it tells if the finish reason is present. and how safe is the response is given by the safety rating, and the feedback is given by the block reason and the safety ratings. Prompt design has a lot of depth and nuance to it. We have a number of guides up on the website. This one is very comprehensive and could be a talk on its own. If you need the Gemini API to perform multiple tasks, you might find it works better when you break the thought into small atomic steps that are chained together. Adding context is also helpful. The model might be able to remember some facts, but they tend to work better when you give them all of their information they need to answer the question. And there are some model parameters you can tweak, things like temperature, top K, top P. This guide explains all of this and how they affect the model. Code generation. The next iteration on top of text generation is code generation. The concepts are the same, but you can request code or scripts as output. Let us see some examples. Generate data. We can ask the model to generate data for us. Here we have requested 3 columns and some sorting. We can ask the model to generate data for us. We see country, capital, and continent. Generate a table that has all the countries in the world listed alphabetically, their capitals, and what continent they belong to. Say we want to generate an SQL query. We can ask the model to generate it for us. This is an example prompt. Generate an SQL query that will query for capitals in countries of Asia following this format: table countries, columns country, table capitals, columns country ID, capital. And here we see the SQL query that is getting generated. Now we will look at how we can simulate execution. What is the output from this command and table? Here we give the SQL query and we give the table. We ask for execution. Do you think you can use Gemini as a smart pair programmer? Yes, you're right. Generate a Docker script to create a small, simple Linux machine that has Python 3.10 installed with following libraries such as Pandas, TensorFlow, and NumPy. And here you go. You get the script and it's all ready. And now we talk about testing and unit tests. We can use this Gemini APIs for getting unit tests. There's some subtle bugs here that might not be obvious by immediate inspection. Let's see what Gemini says. Pretty good. We have some input checks and some type checks. It's worth pointing out that we use a very basic wake prompt here. Since it's free text, you can add any specific instructions you need. Search and information synthesis. A common question when starting with LLMs is, how do I bring my own data? Whether that is asking questions about your internal knowledge base or building a chatbot for your website. All models have knowledge cutoff dates. They were trained at a specific point in time, cannot know about anything that happened after. Because of this, they're limited in their ability to reliably produce facts, and ultimately, some things you might want to ask about may not be public, whether it's your product catalog or files on your computer. The way we deal with this is to supply as much relevant information as we can to the model we make requests. The simplest way to do is to supply contextual information, is to just put it in a prompt. Some platforms call this a stuff prompt, as we just stuff the information into the prompt. What a nice name. Model, and we stuff the prompt, we stuff the information that we want to give. It's simple. Gemini Pro is limited to 30K tokens input, limited to small problems. Gemini 1.5 limits is 1.11 million tokens, handles much bigger problems. Wow. So here we see how it is scaling up and what is the potential of usage of Gemini Pro 1 million. And as we go for Gemini Pro 1 million, we can even have effective retrieval with Jane context. So you can use the prompt context window. It is more flexible than retrieval augmented generation. More input context means higher latency. You can join the waitlist for Gemini Pro model waitlist. The next strategy is through an endpoint we have in the Gemini API. It has a couple of flavors. The first one that will be shown here is where you'll provide inline chunks, where we do the whole process in a single request. So over here, we see your Googler, your Google car that has a climate control that allows and dot, dot, dot. So basically, there are a lot of chunks. So how do you make it less windy? To describe the airflow inside the car, turn the airflow knob counterclockwise. Focus on the green parts. The answer is generated text. The return grounding attribution pointed out which chunk the found answer in. The answerable probability indicates the model's confidence that the answer is correct and grounded in the passages. This is simple, but has some limitations. To work around these limits, we have a way to host the documents you want to query. You can create a corpus that hosts your docset and then upload documents to the corpus. Documents can be large, so they can also be split into chunks. These upload process works as you would expect. Use a chunker to ensure that documents are split along sensible boundaries, not mid-sentence. The system also supports filtering, so you can limit responses to your team's documents, etc. Some limits still exist here. It's not free unlimited storage. Need a different system to expand the past, like Vertex AI vector search. If the backend isn't your SOT, you will need to manage your synchronization. Function calling. This is a Vertex AI example, but it's a nice startup. What percentage of orders are returned? It says 9.95% of orders are returned. This information comes from a table in BigQuery. The query used to calculate, and we have the query there. Function calling is heavier than other section. Function calling is an advanced feature that's unavoidable. The model may ask you to call a function to help it respond to your queries. And you have endless possibilities for integrating external tools. It is limited in what types it can interpret for the API. Here we see in this example how we put some limitations. The function name, description, argument, names, types get passed to the model. So here we have a function multiply. It has input A, B, both of them are floats. And we are sending this to the model Gemini 1.0 Pro, and this returns A star B, a multiplication. Let's know the function calling basics. Because function calling requires alternating terms, it's easier to use through chat. You can enable automatic function calling when you start a chat, and the chat section will call the functions for you. You don't have to use automatic function calling. It just makes life simple cases easier. Here we can see how we can enable automatic function calling. And here is a response that comes to the message, I have 57 cats, each own 44 mittens. How many mittens is there in total? And then the number of mittens get printed. Let's see some basics. What happened? You can use the chat history to find out. The chat history collects all the function calls and responses that took place. For content in chat history, here we can take the 0th part, which tells us what is the role and list of part objects. Now there should be only one part. So here you see there is text, there's function call, function response, and text. We send the query, the model returns a function call, we replied with the result, the model then replied with a text response. Send the conversation history along with a list of function declaration objects. The model might reply with a function call object. You respond to the function call with a function response. The model might send another function call or text response. Shall we see more examples on function calling? Here is a Wikipedia research aid. It integrates a search tool, uses the Gemini API inside the function call to summarize pages. Generative AI model, Gemini Pro. Start chat. Explain how deep sea life survives. Send the chat. You can ask the model a question. It generates a list of queries for the Wikipedia search function to try to answer the user's question. The Wikipedia search function searches for each query, summarizes the text of each retrieved page. Then it returns the list of page summaries as the function response. Finally, the model uses those page summaries to generate the final answer. SQL talk. You can use a function call to talk to the database. Here is a SQL string, and sometimes errors creep in. Here there is schema. Automatically building the schema from the type hints that doesn't work for everything. So here are the different types that are allowed. Let's look how schema is constructed. The model tools property contains an extracted function schema. This is the prototype representation of the object. We see key, we see a value. Schema. It's an open API schema written as a protobuf. The protobuf classes are available in the Google.ai.generative language client library. Here are the reference documents. Here we have a declaration written out using the types provided. Schema, function calling schema. They can be written as JSON compatible objects as well. Here is a JSON, and you try to put A and B with the type number, and you're required to give AB, which is a multiplier. Either way, we pass the description to the model when you instantiate it. The model will pass it along when you call generate content or send or chat send message. Structured data. How does function calling work for structured data? Structured data extraction. You can just ask the model to do it and it returns JSON. Here you see, please return JSON describing the people, places, things, relationships from the story using the following schema. With a strict description, we can strictly enforce that what gets returned. We can get because we can give the schema. Here we have adding database entities to database, how we are using the types, the schema, the name, description, start place name, end place name. This is an example of how we can have function calling for structured data using schema. Here, the properties are different. Either way, we pass the declaration to the model. Why? Why the function calling doesn't return a string? The function calling returns data structures. You don't have to parse the text. You're converting proto to JSON compatible object only for readability. This is the JSON. We have focused on the textual capabilities of Gemini API so far, but that has sidestepped one of the most powerful features, image understanding. Let's start off by demoing some capabilities. Guess the movie. Yes, we all know which is this movie. That's Charlie and the Chocolate Factory. Now, guess the movie and explain your reasoning. The first emoji is a house, which could represent the house that Kevin is left home alone in. The second emoji is a scared face, which could represent Kevin's reaction when he realizes he's home alone. The third emoji is a Christmas tree, which could represent the Christmas season in which the movie is set. So the movie is Home Alone. Guess the name of this book. Can you guess it? The Secret Garden. Guess the movie. It's 2001, A Space Odyssey. These examples were fun. Let's try something that uses reasoning. What do they weigh? Solve this puzzle. It gives a step-by-step reasoning how it is solving. Image understanding. Image are just tokens in the input. It can be used for instructions, context, or query subject. The API is the same as we use for text interactions. We just need to use a model that has vision capabilities. Here we are using the Gemini Pro Vision model. If you use the wrong model, you will get a pretty clear error message back. So here it is. A single turn in the generate content request takes a sequence of input chunks. Each chunk is a single mode or MIME type, so you can interleave text and images in your request. Also, RAG. We don't have an example, okay? We can use retrieval augmented generation here. The JavaScript tip generator, we use the topic as input to the tip. Now we can use the conditioning. We can use that with images too. A fun way is to express this by using images as a creative source. This example uses a hand drawing of a character as the source of inspiration for a character sheet. To demonstrate structured data extraction, we have a paper form that has been filled out by hand. We can take a photo of the form using a smartphone like this and convert it directly into JSON. It's a fuchsia prompting just the way we had seen before in the text context because we are giving example. Here there are lots of lines of code. This is just a schema definition using Python's Pydantic library, similar in concept to attributes or data classes. You download the image to process, provide a prompt that is straightforward, but you can add guidance as necessary here. Load up the Llama Index Gemini model. Build a pedantic parser for the schema we define. Bundle up the images and prompt up the parser. Run that prompt and you get the deeply instantiated object back. Possible activity here that you can try to do is that Gemini model is capable of including some simple conversations. You can try it and see how it works. For example, you can change the age field to age months. You can do changes and see how it works. Moving on to a very important chapter of this session, tuning. How do we tune using Google AI Studio and how do we tune through the API? In Google's AI Studio, click New Tuned Model and then either create a structured prompt or import prompt data from Google Sheets. From Google Sheets, you choose which columns to use as input and output and then import the data. Set the tuning configuration and click Tune. After a few minutes of training, you will find the training run in the file section. Then you can use the model to create a prompt. Tuning using the API isn't much different. You can try it in the Google Colab Quick Start. You can set the training data. You can send the request to launch the job. There's special request for monitoring the job too, which you can try. Once the job complete, you can just use the tune model's name anywhere you could pass a model name. Running inference with this model, you can see how it has picked up the intended task, increment. It gives correct answers in Roman numerals, French, Japanese, and even those were not included in the training set. Permissions. There are permission configurations in the API, but it's not integrated into the SDK yet. Responsible AI. Before we wrap up, I want to cover something very important to think about while working with generative technologies. These models are powerful, but you need to make sure that their output is being used in a way that is safe. Google has published AI principles that use this for their AI products and is encouraged to do the same. The Gemini API comes with a built in safety filter to filter out certain content, and these are enabled by default. Developers are able to change these, but we advise you to do with caution and to make sure you perform comprehensive evaluations along your critical user journeys before deploying them in any real world scenario. For more content, guides, examples, head to our website. There's also a Discord forum where you can chat with our other Gemini developers and team. Thank you.